4.3 Right triangle trigonometry. What should you learn? Evaluate trig functions and acute angles and use a calculator to evaluate those trig functions. How to use some theorem of identities and use the trig functions to model real life problems. So this is one of my favorite lessons in trig. It's like the foundation to all the good stuff in trig. And it starts off with right triangles and how to name them. So like here's your right triangle. Let's say this is our angle right here. And the side opposite of it, say here's our angle, and literally across the way opposite, it's called opposite. We have a right angle here, so opposite of that is the hypotenuse. And then the adjacent side, adjacent means next to, is this, I always think about the leftover side. So one next to the angle though. So you have the angle, you have the one that's opposite of it, right there. You have the hypotenuse, which is opposite the right angle, and then you have the adjacent side, the leftover side. So the ratio of these sides forms our 6 trig functions. We have sine, cosine, and tan. Those are like the big 3. And then we have the reciprocal functions. Cosecant is just the reciprocal of sine. So you just like, cosecant is literally just 1 over sine. Secant is the reciprocal of cosine. It's 1 over cosine. And cotangent is 1 over tan. That's the easy one because it sounds like it. Right, so the real key is just knowing these 3. If you can know those 3, you're going to be golden. Well, what's an easy way to remember the 3 trig functions, which I haven't talked about yet? Sine is the ratio of the opposite one over the hypotenuse. So sine is opposite of hypotenuse. Cosine is the ratio of the adjacent over the hypotenuse. And tangent is the ratio of the opposite over adjacent. So that's sine, cosine, and tan. For short, an easy way to remember this is SOHCAHTOA. Right? And that's all it is. That's all SOHCAHTOA is. It's just an easier way to remember the main 3 trig functions. Because if you have those 3, you're going to have the other 3. And all it is, they're just ratios. Sine of this angle is this ratio over this ratio. Cosine is adjacent over hypotenuse, and tan is opposite over adjacent. That's all it is. So you can see them here. Sine is opposite over adjacent, right? That's where the SO comes from. S lets you know it's sine, and then O lets you know it goes on top, and H goes in the denominator. So when you see SOHCA, right, I see ka, that's cosine adjacent over hypotenuse. And then TOA, tan opposite over adjacent. So remember, this is, by the way, this is a shorthand for sine. It's actually SINE, as you can see up here. Right, these are the proper way of saying them. For short, we just kind of usually do the first 3. That's tangent. And then cosecant is just reciprocal of sine. Just flip it. Secant is the reciprocal of cosine. And cotangent is the reciprocal of sine. Okay, so let's do an example real quick. Using the triangle in 4.2, that's right here, find the exact values of the 6 trig functions. So the first step when I do a problem like this is like to list out all the sides of our triangle here. So if you just do in your head that you want to list them out, so like this is my angle, so I must make this opposite. Here's our right angle, so this must be hypotenuse. Oh, as they let us know already, that means this guy must be adjacent. Before we do the 6 trig functions, let's figure out what this missing side is. Right, anytime you have a right triangle, the easiest way to find any missing side is using the Pythagorean theorem. A squared plus b squared equals c squared. And remember the one key for Pythagorean theorem? The hypotenuse must be the c. That's the only rule. A and b, it doesn't matter which one's which, but hypotenuse has to be c. So in this problem, we're going to do, let's say 3 squared plus 4 squared equals c squared. That's 9 plus 16 equals c squared. That's 25 equals c squared. I'm going to square root both sides, and then we get c equals 5. So that's my hypotenuse, 5. Okay, so now we have all the sides of the triangle. We should be able to do the 6 trig functions really easily. So we're going to have sine, cosine, and tan. And the easy way for me to memorize that is this SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and then tan is opposite over adjacent. And we look at our triangle here, right? Opposite is 4, and hypotenuse is 5, so 4/5. Cosine would be adjacent over hypotenuse, 3/5. And then tan is TOA, opposite over adjacent, so 4. Opposite over adjacent, we right here, 4/3. So those are the main 3 functions. Again, if you know those, you're gonna be set. Because the reciprocal functions, you just gotta remember which one it goes with. Tan's the easy one. Everybody knows tan goes with cotan. That's short for cotan. So you're just gonna flip tan. So if tan was 4/3, now it's gonna be 3/4. Sine goes with cosecant. That's probably the hardest one because it sounds like it should go with secant, but no, it goes with cosecant. So it was 4/5, now it's going to be 5/4. If you know that one, then that means cosine goes with secant. So that's short for secant. And then it was 3/5, so now we're going to go 5/3. And that's how I remember these two. I always remember like it's the opposite of what it sounds like. So sine goes to cosecant, cosine goes to secant because it sounds like the opposite. And I just remember cotan's the easy one. But that's how you do the 6 trig functions. Next, a very, very important part, especially for me, the way we do trig, is you gotta know how to do sine, cosine, tan of 45. And then this is just memorization. So I think about it, like you're gonna see over the next chapter, I'm gonna make you guys memorize a 45, 45, 90 triangle. So here's my triangle, here's 45. It's 45, 45, right? Like you see there. So it's gonna be 1, 1, and then hypotenuse is rad 2. That's just memorization. So 45, you could do a squared, b squared, but like who wants to do that? So it's 1, 1, rad 2. And then here's our angle. So that's opposite. That's adjacent. And then hypotenuse is always rad 2. That's always been the case in a 45, 45, 90 triangle. It's 45, 45, so the isosceles are the same, 1 and 1, and that's hypotenuse. So sine, right, of 45, I should say, equals, well, let's do SOHCAHTOA. SOHCAHTOA. So sine is opposite over hypotenuse, so opposite's here, hypotenuse is there. So 1 over radical 2, we're just going to leave it like that. Cosine of 45, that's SOHCAHTOA, adjacent from hypotenuse, so 1 over rad 2. Sometimes people want you to rationalize that, and I left the first one, but let's rationalize the second one just to practice. Remember, the way you rationalize something, you don't want a radical denominator generally, so you multiply both top and bottom by that radical. So I'm going to get square root of 2 over square root radical, same thing. Square root of 2 times square root of 2, square root of 4, also known as just 2. So either of these, for me, are acceptable. The non-rational version and the rational version. Okay, so we got to do tan of 45. So SOHCAHTOA, opposite over adjacent, and that's going to be opposite over adjacent, so 1 over 1, which is just 1. So those are the exact trig functions for 45, and it's something we're going to do a lot over the next chapter. So you have to get used to your 45, 45, 90 triangles. The other way I get used to is our 30, 60, 90 triangles. Now, I personally, when I do these, I treat them like two separate triangles. I know they're the same triangle, but I treat it like two separate triangles. So I have my 30 triangle. So here's 30. And you can look at the sides here, the ratios, but this is the way I'm going to do it, right? 30 is small, so it gets the 1. Hypotenuse is always 2. That makes this side rad 3. Then I make myself a 60 triangle also. So there's 60. 60 is the big side, so it gets the radical 3. Hypotenuse is always 2, and that makes the side a 1. So that's the way my brain works. I treat it like two separate triangles. And what do they want us to find? They want us to find sine of 60, cosine of 60, sine of 30, and cosine of 30. So sine of 60, right? Sine of 60 is right here. Here's my angle. So sine would be opposite. So over hypotenuse, rad 3 over 2. Cosine of 60, again, this triangle. Cosine SOHCAHTOA, adjacent over hypotenuse, 1/2. Sine of 30, well, here's my 30-degree triangle, right? Sine is opposite over hypotenuse again. So opposite would be this one over hypotenuse. And then cosine 30, SOHCAHTOA, adjacent over hypotenuse. And that's how we're going to do a 30, 60, 90 triangles. So for me, again, it's memorization. We're going to do a lot of 30, 60, 90 triangles. 45, 45, it's 45, 45, it's isosceles, so it's going to be 1, 1, rad 2. Notice that there's always a 2 in the hypotenuse. This one just happens to be a radical. And at 30, 60, 90, 30 is small, it gets the 1. 60 is big, it gets the rad 3. Right? So opposite 30 should be the 1, opposite 60 should be the rad 3. 2 is on hypotenuse. And also notice there's only ever one radical, right? Here it's 1, 1, it's 1, 1, 2 is a ratio, but it doesn't make any sense to square root of 1. It's a square root of 2 that's hypotenuse. Up here it's 1, 2, 3 is a ratio type of thing, but the 3 has a radical. So here's all the special triangles. Some people memorize it this way. I don't. We'll get to those. Here's some basic trig identities. We're going to do more of these next chapter. But some of these we know already. Sine is the reciprocal, well, I should say cosecant is reciprocal of sine, right? So it equals 1 over sine. Cotan is 1 over 10. It works the opposite way also. Sine is 1 over cosecant. Cosine is 1 over secant. Tan is 1 over cotan, right? They're reciprocals of each other. There are these guys. These guys are super important. Tan is sine over cosine. And cotan, since the reciprocal of tan, is the reciprocal. Cotan is cosine over sine. but you have to know tan and sine over cosine. And you also have to know sine squared plus cosine squared equals 1. It's like the fundamental theorem of like trig. It's basically Pythagorean theorem. That's where it comes from. But you have to know that. So sine squared plus cosine squared equals 1. We'll do more of it next chapter. We'll do more of it in a couple of lessons, but it's super important. Also note, anytime you see a square, I don't know why I said it so funny, it means this, right? So sine squared theta, it's the same thing as sine squared theta. So like this one is the same thing as sine theta squared plus cosine theta squared equals 1. We just write this because it's shorter. We don't want to have to write the parentheses all the time, so we write it like this. So it means the same thing. We just don't want to write it that way. Okay, let's solve some more problems. Let theta be an acute angle such that cosine theta equals 0.8. Find the values of sine and tan. So what they want you to do is to use this formula here. So you plug in 0.8 for cosine, solve for sine, and do all that good stuff. What I do is I make a triangle. So this is cosine over 1. I'm going to make a right triangle here. Like that. So here's my angle. Remember, cosine is SOHCAHTOA. So here's adjacent, opposite, and hypotenuse. We're going to put the values where they go. So SOHCAHTOA, adjacent, hypotenuse, right? So this should be 0.8, and this should be 1. Right, I made it a fraction, 0.8 over 1. So I need to find sine of the angle and cosine and tan of the angle. Well, sine is just opposite over hypotenuse. Only problem is I don't have opposite. Well, we could find that. This is just Pythagorean theorem again. So we're going to do 0.8 squared plus b squared equals 1 squared. So I'm going to give it 0.64 plus b squared equals 1. B squared equals 0.36, take the square root, b equals 0.6. So that goes here, and now we can solve the problem, right? What is sine? SOHCAHTOA. Opposite, 0.6 over hypotenuse, 0.1. So 0.6 over 1, or just 0.6. What is tan? TOA. Opposite over adjacent, so 0.6 over 0.8. Once you have two decimals in the same spot, you just drop them. Like times everything by 10, I guess, and you get 6 over 8, or 3/4. So that's how you use. So again, some people like to use the identities. I like to just make a triangle and then fill it in where it's supposed to go. So let's do another one real quick. Let's let a acute angle be such that tan equals 3, and let's find cotan and secant. So we got to find cotan and secant. Oops. Well, one of these we know already. If you have tan, you should know cotan. It's just 1 over 10. So just flip it. So 1 over 3. Done. I do got to find secant though. Secant's 1 over, and it always helps to do reciprocal, right? That's 1 over cosine. So I got to figure out what cosine is and then flip it. I don't know what cosine is yet. So I'm just going to make a triangle real quick. Boom, boom. Tan over, right? Tan, TOA, put over 1. You want a fraction, OA. So the opposite, which is this guy, is 3, and adjacent to 1. So I got to find the hypotenuse, because I need cosine. We're going to do Pythagorean theorem real quick. 1 squared plus 3 squared equals c squared. 1 plus 9 equals c squared. So we get square root of 10 equals c. So that's my hypotenuse. And then cosine, so cosine would be SOHCAHTOA. So 1 over radical 10. But we're doing secant. We're going to flip that. So just square root of 10 or radical 10. So that's the idea. This one, use trig identities to transform one side of the equation to the other side of the equation. So my trick here is generally put everything in terms of sine and cosine. That's my shortcut. We'll do more of this again next chapter, but if you're not sure what you're doing, you generally put everything in terms of sine and cosine. That won't always work. I'm not going to do that here, but I will do it over here. So you have cosine and secant. Don't touch cosine. Let's change secant. What does secant equal? Secant is the same thing as 1 over cosine. So keep in mind, when you do one of these trig identities things, you can only work on one side at a time. So I can't do anything with this. I'm just going to work on the left side. Well, now look what happened. These cancel out. You just get 1. right? That's all I did there. I was like, wait, I know secant is 1 over cosine. So you switched it, these cancel out, you get 1 equals 1. So on this side, right, I got to try to make this guy look like this guy. Now again, I could change everything to sine and cosine. I think on this one might be a little ugly. I'm going to say that for now. What this thing's begging me to do is distribute. So I'm going to do that. I'm going to multiply secant by secant. I get secant squared theta. Secant times sine minus tan secant. I'm going to have to erase this equal sign because I'm running space. And then we're going to go over here. Tan times secant plus tan theta secant theta. Remember when you're multiplying, it does not matter which one goes first. I could have done secant tan. It doesn't matter when you multiply. Then multiply this times this. I get minus tan squared theta. Well, first thing, these middle things cancel out. And I get secant squared theta minus tan squared theta equals 1. I'm still equals 1. I gotta figure this out, right? I gotta show that this side equals 1. Well, normally I would probably change the terms of sine and cosine, but I'm gonna try to make this easier. If we go up to our rules here, I believe they have one that it's either secant or tan equals something. I mean, I know the answer. I'm just waiting for you guys. See here, secant equals 1 plus tan. So we're going to change that. So we know secant is the same thing as 1 plus tan squared. Everything else stays. That's still minus tan squared. And then look what happens, right? 1 positive tan squared minus tan squared. Those cancel out. We just get 1 equals 1. And you showed that those two sides match. So we'll do more of that next chapter, just like a little intro to it, but it's a little, we'll do more of that later. Okay, last things, application problems. So the main thing is this, you're going to see a lot of triangles. You saw them like you saw triangles, SOHCAHTOA, all that good stuff. But the main thing is angle elevation and angle depression. The key thing with those things is you were looking at a horizon. So let's say you have this person here, and this is his eyeball. It's the horizon. That's the normal line. Elevation is above that horizon. And depression is below that horizon. So that's the way it works. So start at the horizontal line, go up, angle elevation, go down, angle depression. Too many times people think like it's just the angle going down or something like that. They're like, oh, it's this one. That's not depression. It has to be from the horizon. So this is angle depression. That's nothing. This is depression. If that makes any sense. And this is a problem. The variable standing 50 feet away from the base of a large tree, as shown in this picture here. Find the measure of the. Basically, we just got to find y, right? So if you look at it, it's really just a triangle. This is 50. This is 71.5 angle elevation from the ground. So that's what my horizon, my ground, and then you go up 71.5. I'll show you what this is. Well, a tree grows in a right angle, so it's a right angle, and all this is SOHCAHTOA. Now, which ones do we have? Let's list it out. Here's my angle. That's opposite. This is adjacent. And I don't have hypotenuse, so I don't care. So the way you figure out which trig function you need is SOHCAHTOA. That's why I love it so much. Use SOHCAHTOA. What do we have? We have opposite and adjacent. That would be TOA. So we're going to use a tan function to solve this. So we're going to go tan of my angle, 71.5. equals opposite over adjacent. So y over 50. And now all I have to do is actually type this into our calculator. So 10, I need my calculator back. This is the last video I was making. Let's go. I gotta make sure I'm in degrees. So if you have a graphing calculator, notice that we're in degrees. You have to make sure your calculator is in degrees. Okay, so I'm gonna put tan of 71.5. And I get 2.904 equals y over 50. And then we're going to multiply both sides by 50. Get rid of that 50 there. I'm going to get 100 or something. So let's put times by 50. And then we get y equals 145.2. We'll say 0.2. So that's how the tree is. The tree is 145.2 feet tall. And I always block the answer with the calculator. Bad habit. There we go. Example 9. Same idea. Like I don't need to read the question, right? Well, actually, I probably should look what the question is. You are 200 yards from the river, so that's right here. 200 yards from the river. Rather than walk directly to the river walk, you want to walk 400 yards in a straight path to the river. So take this like hypotenuse. find the acute angle. So we're trying to find the angle. So again, it's just a triangle. That green on green did not work. I don't know what I was thinking. So here we go. That's our angle. We're going to do the exact same thing. List the sides. This is opposite. Here's the right angle. So this is hypotenuse. SOHCAHTOA. This time we have hypotenuse and opposite. OH. That is so. So we're going to set up again. Sine of the angle. This time we don't know what the angle is. So we're just going to leave theta alone. Equals 200 over 400. Eventually, we're going to use a calculator to solve this, but for now, we actually haven't learned how to do that, so we're just going to reduce this to 1/2. And remember, we did this earlier. When does sine equal 1/2? It's a 30-degree triangle. So 30 degrees. If you remember a 30, 60, 90 triangle, 1, 2, radical 3. Sine was 1/2 at the 30, so it's opposite for hypotenuse. So again, eventually we'll do it with the calculator and we'll do all different types, but that's how they want you to do it for now. Anyway, last one. Find the length of the skateboard. So look at the picture. We're just going to solve it real quick. Here's my angle. This is opposite. This is the right angle, so it's hypotenuse. This looks like it's sine again. So sine of 18.4 equals 4 over c. So this was a little tougher because the math here is a little worse. But we're going to do it the exact same way. Put this over 1. I'm going to cross multiply. So I'm going to get 4 on this side. Then we're going to cross multiply these two. And I get c sine of 18.4. So I have this. And then we're just going to divide by sine of 18.4. And then do that in my calculator. So 4 divided by sine of 18.4. And I get 12.7, we'll say. So that's the length in feet. So the ramp is 12.7 feet long. And that's the lesson.